So hello everyone. The problem which we are going to discuss today is count all the pairs I and j such that b of I plus b of j should be equal to k. Okay. So what does it mean? Let's discuss the meaning of this problem before moving towards the solution. So let's discuss what we have to do in this problem. Let's assume we are given this array. Let me draw the array. The array will be like this and the elements placed inside the array are this 3, 2, 1, 2. Okay, and let's say here 5 is also there, and here let's suppose that k is equal to 4. So now what is the problem asking? The problem is saying that we have to count all the pairs I and j such that b of I plus b of j should be equal to k. That means the sum of those two elements at index I and index j should be equal to this given k. So we have to count all such pairs and we have to print them. Okay, so let's see what are the pairs present in this array. Let me write the indexes also so that it becomes more clear. This is the first index, second index, third index, fourth index, and fifth index. Okay. So guys, as you can see, this 3 can be paired with this one. Don't you think so? That the sum of index element present at index 1 and the sum of element present at index 3 will be equal to 3 plus 1, which is equal to 4. So we can say that array of 1 plus array of 3 is equal to k, isn't it? So we can say that index 1 comma 3 is a valid one, isn't it? If we can say that the sum of elements present at index I and j is equal to k, then we can say that I and j is a valid pair. So we can see that 3 and 1 are valid pairs. Let's similarly find out other valid pairs also. So what are the other valid pairs you can see in this problem, in this test case? You can see guys, this 2 can be paired with this 2. It will also make the sum as 4, isn't it? Don't you think so? That this 2 will get added with this 2 and the sum will still be k, 4. So we can say that this is also a valid pair. How? Array of, what is the index of first 2, which is equal to 2, plus array of, what is the index of second 2 guys? Tell me. The second 2 is occurring at index 4. So guys, the sum of array elements present at index 2 and index 4 is equal to nothing but 2 plus 2, which is equal to 4 and which is equal to k. So guys, if it is equal to k, we can say that index 2 and index 4 are also valid. So the second valid index is index 2 comma index 4. So we can see that we have found we have found two valid pairs. First one is this one, second one is this one. So we have found two valid pairs. Let's see if there is any other valid pair also. This one needs 3. So is there any 3 which is present after this? Also, I am taking this one to show you this, that this 3 has been paired with this one. So can we pair this one with this 3 again? No. How we can ensure that it will not get paired? Like this. I will always be less than j. This is the condition given to us, that the first element should be lesser than second element. Index of first element should come before. So if 1 has come now, the second element's index should be after this, because if this is I, then j should be greater than I. So j should come in this direction only. So can you see any 3 present here from index 4 till index 5? No. So we can say that this one cannot pair with any other elements. So the total number of pairs are 2 only. So the output for this test case would be nothing but 2. Let's discuss another test case to make it more clear, guys. Let's discuss another test case to make it more clear. Let's take the numbers like this: 1, 2. For the sake of simplicity, I am taking these numbers, but it will show you a very good observation. What will be the observation? Just wait, I will tell you. These are the indexes I am writing. Okay, guys. So see, now in this case, my k is nothing but My k will be nothing but 5. Now focus here, guys. See, when you will be at 1, you will find 5 minus 1, which is equal to 4 in right side. So you will see that 4 is occurring at index 4. So you will pair this one with this one. These two will you will try to pair. So let's write the indexes of all the pairs. 1 comma 4 is a valid pair because the elements present at index 1 and 4 are 1 and 4 only, and the sum of these elements are nothing but 5. Okay, so now let's discuss what can be the second pair. Second pair can be uh, yes. So second, for finding the second pair, let's check for one. Is there any other 4 present in the right side? Is there any other 4? No, guys. You can see that for this one only this 4 was present and no other 4 was there to make its sum equal to 5. Now let's go to this index. Now if it is I, you know very well that the second index or j can be greater than I only because it is given that j should be greater than I. So if j is greater than I, it should come in this range. So what is the number or the complement number which should be added to this 2 in order to make the sum as 5? You will subtract it from 5, so you will get 3. So do you find any 3 present in the right side? Yes, this is the 3. This is the 3, guys. So when you will add this index 2 and index 3 elements, you will find that the sum is still is equal to 5. So this is also a valid pair. So the second valid pair is nothing but 2 comma 3. Now let's move to the next index. Let's move to the next index, guys. So when we move to next index, which is nothing but 3, now you will find that we require the sum of 2 because when we are at this point, the subtraction of this number from k will give us 2, so we need to find 2 in right side, which is not there. So we will skip this. When we will come to this point again, we will need to find 5 minus 4, which is equal to 1. It is also not there. So now we will go to this one. When we are here, you will say that 5 is the required sum and 5 is there, so we can take this. No, guys, because we have to take a pair. So single element can't be equal to the pair, so we need another element. So the second element we need is 0. 5 minus 5 is 0, but here all the numbers have been exhausted, so we can say that this index also does not form any pair. So what is the count of pairs for this test case? Again 2, guys. So for this test case, we need to print the answer is 2. I hope the problem is clear to all of you that what we have to do, we have to count all the pairs such that the b of I plus b of j should be equal to k. This is what we have to do. Now let's discuss the brute force approach for this problem. So guys, what do you think? What should be the brute force approach for this problem, guys? What do you think can be the valid brute force approach? Take your time and think, guys. The brute force approach is very simple. What we have followed here is only the brute force approach. Okay. See, the brute force approach is this one. For each index I, we will check all the valid pairs of j. This is nothing but the brute force approach. That is what we were checking. Let's say this is I, then I will check from this index till end. If this is I will check in this part. And if this is I will check in this part. So what is my brute force approach? It is nothing but I will start from index 1. It will go till index n. Similarly, j will start from which index? Think, guys. Since the j should be the distinct one or different from I, so j, one thing is there that j should be greater than I. Second thing is that j cannot be equal to I. So j should start from next available index, which is nothing but I plus 1. So j will start from I plus 1. It will also go till index n, and we will check. If array of I plus array of j is equal to k, then we can say that this is a I comma j is a valid pair. So we will do what? We will increment our counter. In that case, we will do count plus plus. This will be our brute force approach. Let's discuss the code also for this brute force approach. Let's discuss the code as well for this brute force approach. So let me write the code also. It is very simple. What we have discussed now, it is only the brute force approach. So first we will do what? We will take the input. What we will take in the input? Two things. What are the two things? First is this k, second is the size of array, or we can say n. So we will take the input of n, then next to it we will take the input of k. After that, what we will do is nothing but take the input of the array, because we need the whole array elements together. So we will take input of array. After taking the input of array, what we can do, we can use a for loop. First we will declare the counter variable, which will count all the valid pairs which we have found. So we will initialize our count as 0 initially, and as soon as we get any pair, we will increment it by 1. So from 0 it will become 1, then it will become 2. So what we will do, we will initialize count is equal to 0. Then what we will do next to it, we will start our for loop from index 1, or if it is a 0 based indexing, it will start from index 0. It will go till index n minus 1, and after that what will happen for each I do, you already know what can be the valid j, what can be the starting point of j. We have already discussed that j is always greater than I. So the next available index for the j is nothing but I plus 1. I plus 1 is the next available index, guys. So j will start from index I plus 1. It will also go it will also go till index n minus 1. So we will do I less than n and j plus plus. Now you know what we have to do. First we will take the sum. Int sum is equal to array of I plus array of j. This is how we will take the sum of these two numbers at present at the index I and j, and then we will do nothing but we will check if this sum is same as the required sum, which is equal to k, this k. So we will check if our sum is equal to k, then we will do what, we will increment our counter variable, because we have found one more valid pair. Otherwise, if it is not the case, then what we can do is nothing but we can move to the next iteration. So after doing completing all these for loops, after this completing this all the for loops, at the end we will have the count, updated count variable. So now we just need to print this count, because now we have found what the count of valid pairs. So now we will do nothing but print this count. This is the pseudocode, guys. Pseudocode of our brute force algorithm, which we have discussed so far. So let's run and find the link of this code, and let me paste it in the doc. So what was the brute force approach? It is nothing but taking all the valid pairs, iterate over all I and j, and check. And then what we can do, we will check if array of I plus array of j is equal to k. That means we have found a valid pair. Increment count by 1. This will be our brute force approach. At the end, what we will do, at the end, print this total count, isn't it? And what is the link of brute force approach? This is the link of pseudocode. And the actual C++, Java, Python codes are also there. Let's see what is the C++ code saying. It is same as the brute force approach, guys. This is the input test case I have taken, and here I am calling this function. In this function, I am doing this thing again, what we have done in the pseudocode. We have initialized our counter variable, and we are checking for all the valid I and j, and we are checking if array of I plus array of j will be equal to k, then we will say that it is a valid pair, so we will increment our counter. Similarly, for Java and Python also, it will be the similar one. For the Java code, it is quite similar to the pseudocode. This is the sample input test case. We are calling this function here, and here I am taking the I and j. These all are the valid indexes only if it is the sum of array of I plus array of j is equal to k. Then it is a valid index. We will increment our counter. Similarly for Python 1, again we will do this thing that we will check for all the valid I and j, and we will check if it is the sum is k, then we will increment our counter, and finally we will return this count and print here after calling this function. So I hope the brute force approach is clear to all of you. Now let's see how we can optimize this problem using hash maps. How we can optimize, guys? See here. Let me show you here itself that, let me erase firstly. Okay. So okay, see guys. Initially the count will be 0 and these are the elements. So now what we will do now, we will do nothing but this one. See guys, do you agree that we will traverse from left to right, and at each index I, what we were doing, we were starting j from I plus 1, it is going till n minus 1, and we were checking if I and j are forming a valid pair, then we will increment our counter. This was our brute force approach. So rather than starting each time j from index I plus 1, can we not do something like, if we are at 3, if we know that in the past we have got 1, then we can say that this is a valid pair. Rather than looking at 1 in the future, we are taking for 3. Let me tell you again what I'm saying, that what we were doing earlier, that if I was at index 1, then I was checking when is there 3 present in the right side, because 5 minus 1 is 4. Okay, so is there 4 present in the right side? So we were checking with the help of j loop, starting from I plus 1, that is there a 4 present in the right side. So what we were doing again and again same thing of j loop, which was very complicated and taking time. So to optimize this j loop, what we are saying, that rather than checking in the right side, what we can do is, when we arrive at this 4, then we already know what are the elements present in the past. So we can check if 1 is present in the past, then we can say that this is a valid pair. So it will be same as when we are at 1, we are checking for 4. But now what we will do, using the hash map, we will put all the elements in the hash map, and what we will do, the key will be nothing but the element, key will be element, and value will be its occurrence. So let's say if I have got this one in the past, so its value will be 1 because it is present, that is why it is 1. Similarly, when I will go to 2, I will write 2 as 1, 3 as 1. So now what I will do, when I reach this index 4, I will check what is the complementary element which I need. I will calculate that 5 minus 4 is 1, so I need 1. So I already have the past record, and I can directly check if 1 has come in the past. So when I will try to check here, I will see that 1 is present in this hash map and its value is 1, that means it is present in the past. So I will directly increment my count. And now after doing this, I will go to next element and again check. For 5, I will check if 0 was present in the past. So let's do the dry run for this approach so that it becomes more clear to you guys. Let's take a new hash map and directly do the dry run for this test case only. It will make it more clear. So let me empty this. Okay, nice, fine. This is the hash map, guys. Key will be the element and value will be its occurrence. Okay, so when we are at 1, we will check what is the complementary element which we need. Complementary element in this case will be nothing but 5 minus 1, which is equal to 4. So we will check if 4 was present in the past. So we will see that hash map is initially empty. So it means that 4 was not there, because the entry of 4 we cannot find here. So we will move to next index. But before moving to next index, what we will do is, we will create the entry for the current element if it is not there. So 1 is not present here, so we will create the entry. Why we are creating the entry now? Because in the future any other element like 4 can need this one to make a valid pair, although 1 cannot form any valid pair now currently at current moment with any past element, because in the past there is no 4, but in future there can be any 4 now. So that 4 will find the one using its past record. So we have to update our past current record so that the past record for 4 will be clear. So we will do what, we will make the entry for 1. Now we will go to this 2. We will find the complementary element, which is 5 minus 2 3. So we will check, is 3 present in the hash map? No. So we will move to next index, but before moving to next index we will create the entry for this 2 if it is not there. So it is not there, we are creating the entry. Why we are doing it? Again the same reason, that although there is no 3 present in the past, but in future there can be any 3 now. So we are not using for loop this time for the j to know whether 3 is there in the future, but when we will reach this 3 we will check for this 2. So if we have not created the entry for this 2, then how we will check whether 2 was there in the past or not? So we are creating the entry for 2. Now we will go to this 3. Now what we will do, we will find this time this hash map will help us, guys. This hash map will help us. So now we will calculate the complementary element. Complementary element is this time, guys, 5 minus 3, which is equal to 2. So the complementary element is 2. So we will check, is 2 present in the past? Yes, guys. This time you will notice that this 2 is present here in the past. So what we can do, we can now increment our count because we have found a valid pair ending at index 3, which is that this 3 and this 2. The sum of these two is 5. See, guys. Similarly, before moving ahead to next index, one additional thing we need to do, guys. One additional thing we need to do. What is that additional thing? Is that to create the entry for this 3. Why? Because let's say if here it 2 is coming again, so this 2 will find 3 in the past. So if we create the entry for this 3, this 2 will get paired with this 3 now. So we need always to create the entry, guys. Okay, if it is not there. So let's move to the next index. When we move to here at this index, we will now check for this complementary element. What is the complementary element, guys? First of all, tell me what is the complementary element for 4. For 4, the complementary element will be 5 minus 4, which is equal to 1. So now we will check if 1 is there in the past or not. Yes, guys, when we will check this hash map, we will come to know that 1 has been there in the past in the left side of this map array. So what we will do, again we will increment our count because we are sure that we have found one more valid pair, which is nothing but this one and this current element, which is 4. Now we will move to next index and 5. So this time the complementary element will be 0. So the 0 is not present in the map, so it means that it is not happened in the past. Also, before moving to this 5, we will create the entry for 4, so that in future if 1 is there, it will get mapped with this 4. Okay, so this is how we will perform this approach, which is the optimization of the earlier brute force approach. Let's write the pseudocode also for this approach. Okay, let's discuss the pseudocode as well. So okay, so the pseudocode is quite simple. Let's write the pseudocode, guys. Firstly, we will do what? We will take the input. Input of what? Input of n and input of k. These two things we will require in the input. Also, one additional thing we require in the input, guys. Do you know what is that? This array, guys. This array we need in the input. So we will take the input of this array also. After doing this, what we will do next to it is nothing but we will write the check function, or not check function, count function, int count, which will return the count of all the valid indexes. Okay, in this count function what we will do, we will create a count variable which is equal to 0. Count is equal to 0 initially, guys, and now we need another thing. What is that? This map, guys. Key value pair will be stored in the map only now. So we need to initialize our map also. We need to declare this map, which we can easily do using this map function. And after doing this, what we need now, we will traverse from left to right. We will go in this direction and we will check. Firstly, we will check find the complementary element. We will check if it is there in the map already. Then we will increment our counter, and whether it is there or not. One thing we will do for sure before moving to the next index, which is this create entry for this current element in this map if it is already not there. Okay, so let's find the first of all, let's start the for loop. Int I will start from index 0, it will go till index n. And now what we will do at each index I, we will find the complementary element. Complementary element will be nothing but the k minus current element. Why we are doing that? Because see, if array of I plus array of j is equal to k, then it does not mean that if we are now finding the array of sorry, if now if we need array of j, can we not do that? Array of j will be nothing but k minus array of I, isn't it? Don't you think so? We can definitely do this. So that is what we are doing. This is our complementary element. To find the complementary element, we will do what? We will do k minus array of I. This is what we will do. So that is what we are doing, that we will do k minus array of I. After finding this complementary element, what we will do is we will check if this found complementary element exists in this created map or not, whether it is there or not. So we will check if map dot found find this complementary, if map dot find complementary element not equal to map dot end. In that case, what we will do? In that case, what we will do? It means that it is there in the map. That is why it is not has reached the end of the map. So in that case, we will increment our counter. We will increment our count plus plus. Why we are doing that? Because let's say if I am at this point 4, I will calculate the complementary. It will come as 1. So I will check if it is there in the map. Yes, 1 is there in the map. That means we have found a valid pair. Na? So now we need to increase our count. So we are increasing or incrementing by 1. After doing that, we are doing the next thing, which is nothing but updating in the map for the current element. Why? Because let's say if I am at 4, in future let's say if 1 is coming, so we need to check whether 4 has come in the past or not. So how we will make sure that 4 has come in the past or not? We will create the entry for 4 in this map. No, so let's create the entry for this 4. Map of current element is what, guys? Array of I. So we will do this map of array of I is equal to 1. After doing this, what is the next step which we need to do? Nothing. Everything will get automated after this, guys. As soon as we create the entry, we will move to next index by I plus plus. Then again, it will happen. We will find the complementary element. If it will be there in the map, we will increase our count. And whether it is there or not, we will always do this thing that we will update the entry of the current element. After doing this, what is the next step which we need to do, guys? The next step which we need to do is return this count, because this is the count of the elements which are forming the valid pairs. And finally we will print this count after calling this function in the main function. Okay, we will print this count function. This is how it will work. Let's create the link and paste in our doc for this pseudocode. So for the optimized approach, pseudocode is this is the pseudocode for the optimized approach. And what is the optimized approach, guys? It is nothing but at each index we will we will do what? We will find a complementary we need. Now we will check if this complementary element is present in map already. Then in that case what we will do, we will do count plus plus. It means that we have found a valid pair, and after doing this we will now update entry of our current index element in map. This is the thing which we will always do, guys. Okay, now let's check the C++, Java and Python codes also, so that we can have the knowledge of all the languages codes also. So see guys, this is the C++ code for this problem, which is same as the pseudocode which we have discussed so far. This is the input test case which I have given, and this is the function which I am calling, and I am printing the count of pairs. It was giving the correct output as 3 for this case. Okay, so now let's check what it is doing. It is doing nothing but the same as the our this brute force optimized approach, what we call pseudocode. So it is same as the pseudocode. First we are declaring the map and count in this function, count function. So in this count pair function we are declaring this map which is known as frequency, and this is the count variable which is initially 0. So now we will do what, we will go to every index, and first of all we will find the complementary element, and we will check if this complementary element is not present, no, not equal to n, that means it is present. So if this complementary element is present in the map, in that case what we can do, we will increase our count, and after doing that what we can do, we will update our entry, because let's take a test case, guys, and show you why we are doing this. Okay, let's say the elements present in this array are this. Okay, so now if a is 4, what we will do, first we will go and create a hash map, then we will make the entry for this 3 as 1, because for this 3 complementary element is 1 which is not there in the past, so we will move forward, but before moving forward we will create an entry. Now when we come to this, now we will check what is a complementary element which is equal to 4 minus 1 and 3. So we will check if 3 is there. Yes, 3 is there. So what we will do, we will increase our count, guys. We will increase our count from 0 till to 1. It will become 1. But guys, one more thing that we will always do. Why I am saying we will always do, because of this reason, that let's say in future any other element requires this one, so we need to update the entry for this one also, no? So we will create the entry of 1 and 1 in here, and when I will move to this 3, I will check if 1 was there in the past. So if I would have not updated here, how we will check? So that is why we are updating. Now we will check what is the complementary element is 4 minus 3. So we will check which is equal to 1. So we will check if it is present in the map. Yes, it is present. So what we will do, again we will increase our count from 1 to 2, and we will create the entry for this 3. It is already there, so we will move forward to 2. For 2 we will check what is a complementary element. 4 minus 2 is 2. It is not there in the map, so we will move forward, but before moving forward we will create the entry. This is how it will work, and finally we will return our count. Now let's see what is the Java code saying. The Java code is also similar to the C++ code. Nothing extra we have done, just the same thing. This is the input test case, guys, and this is the value of k, and this is the function which I am calling here. Then inside this function what I am doing, I am checking the count. This is the initially count will be set as 0, and this is the map which I have declared. Now what will I do? I will go to each index and I will check what is the complementary element which is present at that index. So complementary element for every index, how we were calculating is nothing, very simple. We were doing k minus array of I, isn't it? This is what we were doing to find the complementary element for every index I. Similarly, at this point also we will do the same thing only, that we will find the complementary element. And now what we have here, I have created the map with the name as scene. Okay, so we will check if scene is contains the key. N- what is the key here? Complement. Already we have discussed that key will always be the element. Okay, see, here I have explained that the key is nothing but the element, and the value will always be 1 because it will tell us whether the element is there or not. So key will always be the element. Okay, so we will check if this key is present in this scene map. If it is there, that means we have found a valid pair. So in that case, what we will do is we will increment our counter. After doing this, what we will do, we will update the entry for the current element also, na guys. We have to update the entry for the current element also. So we will do scene dot put b of I comma I. This is what we are doing. We are creating the entry for the current element. Okay, now after doing this, we will return our count. Similarly, for the Python code, again we are doing the same thing. In the Python code also we are doing the same thing, that we have created the test case. We are calling this function, and in this function, what we are doing, is nothing but we have created a count variable. Then we have created this map which is known as scene. So in this map, what we are doing is we are traversing to each element of this array. After traversing, what we will do, we will find the complement. And after finding the complement, what we will do, we will check if this complement is present in the map. It means that we have found a valid pair, then only it is present in the map. Because let's say if I am at this index, let's say if the elements were 2, 1, 3, and if my k is equal to 3, and now when I am at this index, I will calculate the complement, which will be 3 minus 1, which is equal to 2. So I will check, is 2 present in the map? Yes. In the past we have got this 2, so it will be present in the map. In that case, what will I do is nothing but I will increase my counter because I have found a valid pair. So after doing that, what is the next thing which we will do? We will have to update the entry for current 3 na, current 1 na, because already told that in future, let's say again 2 is coming. So then what will be our complementary element? In that case, our complementary element will become 3 minus 2, which is equal to 1. So if we have updated the entry for current 1 in the map, then only we will be able to know whether 1 was there in the past or not. After creating this entry, we will do what we will return our count, and finally we will print this count after calling this function. And this is how we will do this problem. And now, this was the optimized approach which we have optimized using the hash map. And what is the overall approach we followed? That at each index, we will find a complementary element we need. Now we will check if this complementary element is present in map already. If it is there, we will do count plus plus. And now we will now update the entry of our current element in the map also. So this was the whole approach for this problem, guys. I hope you would have understood the problem. Thank you for watching this session.